In today's lesson, we're learning how to calculate the length of a line segment. Calculating the length of a line segment is based on the Pythagorean theorem. As you can see, this is a right triangle. I'm going to call this leg A, I'm going to call this leg B, and I'm going to call the hypotenuse C. You should remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. However, if I wanted to, I can reverse this and just say c squared is equal to a squared plus b squared. Now, if I wanted to figure out the length of c, I would isolate c by square rooting both sides of the equation. And that would become c, and that would become the square root of the sum of a squared and b squared. We have a line segment with endpoints A and B. If you recall, the slope of this line segment can be represented by rise over run. If you visualize the slope, you'll notice that the rise and run make a right triangle. Since this is a right triangle, that means we can apply the Pythagorean theorem, which means if we take the run squared plus the rise squared, that will give us d squared. And you can see that right over here. The only difference is that I've isolated d by squaring both sides of the equation. However, there must be an alternative to using run and rise, as you'll not always be given a diagram to work with. And there is. You can use this equation instead, which uses the coordinates of the endpoints of the line segment. As you can see, the difference between the x-coordinates would give you the run, while the difference between the y-coordinates would give you the rise. In our first example, we want to calculate the length of the line segment defined by each pair of endpoints. The first thing you want to do is label the endpoints. I'm going to arbitrarily call point A point 1. So that's going to be x1, y1, and point B is going to be point 2. So that's going to be x2 and y2. Let's begin by writing the equation for length of a line segment. Next, we want to sub in our known values. So instead of writing x2, I'm going to write 3 in brackets. Instead of writing x1, I'm going to write 2. Instead of writing y2, I'm going to write 5. And instead of writing y1, I'm going to write 1. Once you get to this point, you need to observe bedmass, which means we need to do whatever is in the brackets first. So 3 minus 2 is 1, and 5 minus 1 is 4. Next, we're going to use our exponents. So 1 squared is 1, and 4 squared is 16. 1 plus 16 is pretty simple. That's going to be 17. And the square root of 17 is going to be some sort of decimal. I'm just going to leave it as a square root since it's an exact answer. Therefore, the length of the line segment is the square root of 17. In our second example, we want to calculate the length of the line segment defined by each pair of endpoints. I'm going to arbitrarily call point E point 1 and label this x1, y1, and I'm arbitrarily going to call point F point 2, so that becomes x2, y2. I'm going to begin by writing the equation for length of a line segment. Next, I'm going to substitute in my known values. Instead of writing x2, I'm going to write 8 in brackets. Instead of writing x1, I'm going to write 4 in brackets. Instead of writing y2, I'm going to write -1 in brackets. And instead of writing y1, I'm going to write 0 in brackets. At this point, we need to simplify by using BEDMAS, which means we're going to do whatever's in the brackets first. So 8 subtract 4 is 4, and -1 subtract 0 is just -1. So next we're going to need to simplify using the exponents. 4 squared is 16, and -1 squared is the same thing as -1 times -1, which gives you +1. So that should be pretty simple. 16 plus 1 is 17, and the length of the line segment is the square root of 17. You can always change this to a decimal, but if you leave it as a square root, you will have an exact answer. In our last example, we want to calculate the length of the line segment defined by each pair of endpoints. I'm going to arbitrarily rename point H point 1. So that's going to be x1, y1. And I'm going to arbitrarily rename point G point 2. So that's going to be x2, y2. To start, I'm going to write the equation for length of a line segment. Next, I'm going to sub in my known values. Instead of writing x2, I'm going to write 2. And instead of writing x1, I'm going to write -6. Instead of writing y2, I'm going to write -3. And instead of writing y1, I'm going to write -5. We're going to need to simplify by using BEDMAS, which means we have to do whatever's in the brackets first. 2 minus -6 is the same thing as 2 plus 6, which is equal to 8. And -3 subtract -5 is the same thing as -3 plus 5, which is equal to 2. We need to further simplify this by taking care of the exponents. 8 squared is 64, and 2 squared is 4. When I add this up, that becomes 68. Therefore, the length of the line segment is the square root of 68. You can change this to a decimal, or you can leave it as a square root. Leaving it as a square root would leave an exact answer.